Hello, my name is Russell Pederick and I'm the product owner for the OS 2200 feature within the AB Suite 8.0 project. And this presentation is part of the AB Suite 8.0 new product information transfer, and it's specifically about the implementation of AB Suite for the OS 2200 platform. In this presentation, I'll start out by giving an overview of the concepts and the approach that we've taken for implementing AB Suite for the OS 2200 platform. And then we'll get into a demonstration. Now, in the demonstration, I'll focus on demonstrating the noteworthy features. Those are features and functionality that's perhaps significantly different to how the same functionality existed in EAE for the OS 2200. And I'll also look at features that are implemented in a way that's significantly different to how they're exposed in AB Suite for the other platforms, that is Windows and MCP. I'd like to talk about the approach that we've taken to implementing AB Suite for the OS 2200 platform. First of all, one of the most important points is that we have reused the OS 2200 runtime environment from EAE. So the new AB Suite runtime environment is virtually identical to the runtime environment from EAE. We've taken a lot of the code from the EAE Direct Generate client and we've ported it to the new AB Suite OS 2200 builder. And in that context, we've taken the code generation skeletons and templates from EAE, and they've been reused unchanged within the OS 2200 builder for AB Suite. And the net effect of all of that is that the source code files generated by the AB Suite builder are essentially the same as for EAE. So let's look at some of those points in a bit more detail. And let's just start off by looking at what we have for EAE. So on the left-hand side, we start with our model in the EAE developer. And then we have the Direct Generate client component. It reads the model out of the EAE developer and generates a set of source code files. They get uploaded to the OS 2200 host, where the build server picks them up, compiles them, links them, creates, reorganizes the database, and installs the system into the EAE runtime environment. Now, so let's look at the new parts of AB Suite that get introduced to this picture. So first of all, we have an AB Suite development environment hosted in Visual Studio. And that's something we already have. So we're already able to take a model from EAE, extract it out of EAE, and then import it to the AB Suite developer and essentially migrate our model to the AB Suite development environment. Now then, for this project, the main new component that we've created is the AB Suite OS 2200 builder. And this is a new component. It will read the model out of the AB Suite developer and it will generate a set of source code files. And those source code files will be uploaded to the target host, where they're picked up by the build server and treated in exactly the same way, compiled and linked and installed into the runtime environment. Now, the runtime environment for AB Suite is virtually identical to that for EAE. We've essentially just rebranded or relabeled the runtime environment to say AB Suite. But apart from that, there have been essentially no significant changes. For example, here's an image of the splash screen that you see from a TIP terminal signed onto the system. It's clearly labeled as AB Suite and it says Agile Business Suite runtime for OS 2200. But internally, the runtime environment is the same as for EAE. So let's look at some of the aspects of that. The fact that we're using essentially the same runtime means that the generated files that we create and use must be compatible with that runtime environment. Now, to help us do that, let's look at the approach we've taken. So one of the key factors is that we've taken a lot of the code from the EAE Direct Generate client, a lot of the code that generates the source files, and we ported it to the new AB Suite builder. So instead of reading from the EAE developer and generating COBOL generated files, we've ported them so that they read the same information from the AB Suite model and generate the same output. To help do that, we've ported the skeletons and templates exactly as is with no changes whatsoever. The skeletons and the templates really define the structure and content of most of the generated files. And by using them exactly as is, then it means that the generated files that we create are virtually identical to EAE. Now, so the set of files that are generated, we have the same set of files get generated, and the contents are also essentially the same or almost identical, right down to the point where you can actually do a file by file comparison of files generated from a model in EAE versus files generated from a migrated model in AB Suite. And those comparisons show that they're almost identical. There are just a few minor changes, so that things like version numbers, dates and times, some labels and comments might be a bit different. Sometimes the order of code will be a bit different, but that would always be in situations where it's not significant. For example, in an iSpec COBOL file, it has a lot of copy procs are included via copy statements. Now, the order of those is not significant, and in AB Suite, those sequence of copy statements might be in a different order, but it is still logically equivalent. Now, I guess the underlying reason why we've taken this approach is really to allow us to fast track the development of AB Suite targeting the OS 2200. And we've been able to do it with a relatively small development team. I guess you could call this phase one of the AB Suite journey for the OS 2200. Now, some of the benefits of this, reusing significant parts of the EAE environment, is that the resulting runtime system is essentially the same as it was in EAE. So AB Suite generates the same files, the same file contents, and that means that you will end up with the same runtime behavior, the same runtime performance, the same compatibility with other parts of the system, with external systems, with all of your interfaces, and so on. Now, some of the consequences of this, by using the same runtime environment and a lot of ported generation code, means that the capabilities and functionality that we're able to expose with AB Suite is essentially limited to what can be supported by EAE. So therefore, you can do in the development environment of the model only what can be done in EAE. One example is performable global logics. So in AB Suite, the equivalent of a performable global logic is a method. And in AB Suite for Windows and MCP, methods are more flexible. So you can also include methods in iSpecs and reports, and methods can have parameters and return values. However, the EAE runtime and the EAE generated COBOL doesn't support methods in iSpecs and reports, or method parameters or method return values. So therefore, AB Suite for OS 2200 doesn't allow methods in iSpecs and reports, doesn't allow method parameters or return values. You can only have methods under the segment, and they can't have parameters. And there are a number of other limitations like this, and they're all enforced by the AB Suite development environment. And I guess going forward in future releases, we have an opportunity to enhance the AB Suite functionality that is supported for the OS 2200 platform. AB Suite supports 3 platforms: MCP, Windows, and now OS 2200. However, an OS 2200 model doesn't support cross-platform development. There are significant differences in the way features have been implemented in AB Suite for the OS 2200 that make them incompatible with MCP and Windows. Therefore, a model that targets OS 2200 cannot also target MCP or Windows. Now, this model type is essentially determined by the configurations you define, or specifically the configuration platforms. When you create a new model, part of the new application wizard is to create the first configuration, and you're required to select the platform for that configuration, as in the screenshot here. If you pick OS 2200, then your model becomes an OS 2200 model, and then you can no longer add MCP or Windows configurations to that model. And vice versa, if your initial configuration is for MCP or Windows, then you won't be able to later add an OS 2200 configuration. The migration from EAE works in a similar way. It uses the target host setting on the business segment options dialog box and also the available generate sets. Now, to successfully migrate an OS 2200 model to AB Suite, the target host property must be set to only OS 2200, and you must have only OS 2200 generate sets in your model. If you do try and migrate a model that has a mixture of either target host settings or generate sets, then the migration will actually prioritize MCP and Windows, and it will drop the OS 2200 generate sets and target host setting. I'd now like to do a demonstration of the software. As I mentioned before, I'm going to focus on the noteworthy features. So I'll focus on features that are specific to the OS 2200 and also other features of AB Suite where the implementation for the OS 2200 is a bit different to the other platforms. I'd like to start out by creating a new model for developing to the 2200. So within the Visual Studio environment, let's start with New Project. And we're going to use the New Application Wizard. Select that and press Next and Create. Now, there are three modes that AB Suite supports: Standard Mode, Advanced Mode, and User Experience Mode. Well, OS 2200 model must be a Standard Mode model. OS 2200 is not supported under Advanced Mode or User Experience Mode. So press Next. Now we create a configuration, the initial configuration, and this is where we determine what platform we're going to target. So here I have a configuration name specified. Now we select the platform. I'm going to select OS 2200. This is what defines my model as an OS 2200 model. If I wanted to create a second configuration here, and let's just say I choose a different platform, we'll get an error. Not valid to have a mixture of platform configurations if one of them is OS 2200. So we can't do that. If we have OS 2200 configurations, then that's the only platform that we can target. And so we'll just complete the wizard. The other way to create an OS 2200 model is to migrate an EAE model from EAE to AB Suite. Just extract your EAE model and import it into a new model database in AB Suite. The important thing is that it is set up as an OS 2200 model in EAE. So if we look at the business segment options of a business segment, the target host setting must be set to just OS 2200. If you have a model with multiple platforms selected in target host like this, then the import into AB Suite will actually prioritize Windows, and it would not allow you to target the OS 2200. So you must make sure that the target host setting is set up like this with only OS 2200 selected. During the course of this project, we've been building up a demonstration model that demonstrates in a simple way the use of all of the features we've been developing specifically for the OS 2200. The latest version of this demonstration model is called ABS Demo, and a copy of this will be made available to you. During the 8.0 project, we released a series of technical previews and also a beta release. Now you can see a number of folders here. This folder here, Technical Preview 1, this contains the elements that we introduced in Technical Preview 1, a series of simple iSpecs. In Technical Preview 2, we introduced new features, some global attributes, some new types of iSpecs. We introduced methods. In Technical Preview 3, here we have an example of a folder, a deployable folder that represents component enabler generation. This is used to define a component enabler bundle. We also introduced reports in that technical preview, and some simple reports are included here. So that explains the folder structure of this demonstration model. And incidentally, my solution also includes an ATT project. This one here, ATT ABS Demo. This is an AB Suite automated test tool project. And I use this to record a series of online sessions. So recording a series of iSpec transactions and their responses. And they're all gathered up into this test project. And this can be replayed at any time. The online transactions get replayed and the results get verified. Here we're showing the Test Explorer window at the conclusion of a successful run. So listed here are all the individual tests. Each of these represents a session with a series of iSpec transactions. And we can see all the green ticks, it's been successful. A summary over here of 7 tests in the group, ran for a total duration of 38.5 seconds, and all 7 tests passed. A very effective way of ensuring that as a result of changes I've been making, I haven't broken any functionality in my system. I'd like to start by looking at some of the OS 2200 specific configuration properties. So let's start with the top level deployable folder. So I right click Properties, and we can see this folder is deployable. We've specified that we're going to deploy application components, that is the online system and the database. I've got deploy reports set to false in this folder because we've got some other subfolders down lower in the model that represent groups of reports that we want to deploy, and they're set up as report deployable folders. Here's an important property, the port number of the build server on our OS 2200 host. And by default, the FTP will use port number 21, but if you want to use different port number, you specify it here. And let's just scroll down. Another important property, obviously, is the one right at the bottom, deployment host. This is the name or the IP address of our deployment host. Now I'm going to need a definition of packs, so I've set up a location object. Let's look at the properties of that. So fix storage pack is false. Let's look at its definition here. This is defined as equipment type FMD, and this is where I put the name of my packs, my pack or packs. Now, let's look at the properties under the segment. So right click on the segment and properties. And you can see on the left-hand side that we have 4 groupings of properties. The first RDMS properties, I'll leave them as default. Under the deployment, this is where we specify our location objects to represent the packs for the different parts of our system. Under environment, I'm going to leave them all as default. And general, there's a few properties of interest here. Up the top, we have our component enabler properties. Moving down, under the generate category, we have our environment name. On our OS 2200 host, we've set up the AB Suite runtime environment. It's called ABS 8R0. Tip transaction ID for this system, HV tip library number, DIP transaction number, and miscellaneous other properties, quite a lot of them down here. We can scroll all the way down. In this particular system, almost all of them are left at their default values. So let's just have a quick look at some Visual Studio properties. So these are properties that pertain to this instance of Visual Studio and impact the building to the OS 2200. So we go under Tools, Options, and there are options for many aspects of Visual Studio and the use of many languages. But right down here, you'll see there's an entry for System Modeler. Let's expand that and let's expand Builder. And the properties of interest under General, there is number of build threads. So we can set that to have multiple build threads. And we also have an OS 2200 tab here that just has a couple of properties relating to FTP. The first property specifies whether it uses active or passive FTP. There are some environments where you might need to use passive FTP, and also allow parallel FTP. So whether FTP operations are allowed to overlap, and specifying that will greatly reduce the elapsed time of a build. So let's now start a build of this system. I'm going to want to do a build of the complete online system and all reports. So I'm going to start with right-clicking on the top level folder, and I can select build. So a build by default is going to do a change analysis process and work out what's changed since the last build and only build the required artifacts. But just for the point of the exercise this time, I'll do a rebuild. It's going to rebuild every file. Okay, the first stage is to start the build by filling in the host login dialog box, specifying the user code and password for logging on to the target host, and by default using the same user code password for FTP. And down the bottom we have a little collection of properties. First one here, retain existing database. That's fairly self-explanatory, I think. Install system reports. So by default, the build will generate all files, transfer them to the host, compile and link them, and then install them on that host. If I uncheck that, then it will stop just short of the install. And then you can come along later on your target host and use the LRU configure process to install your system. But for now, I'm going to set this build going. I'll enter my password, of course. And then we'll fast forward through to the end, and I'll come back and we'll just go over the build log just to see what's happened, and I'll point out a few points of interest. Okay, so our build has completed. We can see here that the build has succeeded. So let's now have a look through the build log. Let's go back to the top of the build log. I'll point out a few things of interest. So first of all, starting my build from the top level folder, it's done a recursive search down through the model to find deployable subfolders. And it's found several. It's found several here that represent different groups of reports to be incorporated into this build. It's also found a deployable subfolder that defines a component enabler bundle, and it will generate all of the component enabler clients for that bundle. Okay, so it's logged onto my server. It's retrieved a version number from the server, and it's going to use that to match up with local information to perform the change analysis process and work out what's changed since the last release. Not so important this time because I've done a rebuild, but that would be important for a build. Okay, so first of all, it does do a validation phase. So if there are any logics that need to be validated, they will be validated at this point here. This was fully validated. So it's moved straight into the generate phase. And this consists of running a whole series of target builders representing the generation of each individual file. It starts out by generating some of the important files, such as here, the database definition files, the link control file, the segment ICP program source, and then it moves into the iSpec specific files. So this target builder is for the iSpec COBOL file for a specific iSpec, and it generates sections for the screen dollar data file and link GLIS dollar file for that iSpec. And then later on at the bottom of the build, it will gather up all of those screen dollar data sections and amalgamate them into a single screen dollar data file. So let's scroll on down build log. Here's the generation of our component enabler client source files. Here we've completed the generation of all the source files. They've been generated and transferred to the host. And at this point, the build client passes control to the build server on the host. And the deploy phase is now proceeding under host control. And you can see from the timestamps here that that takes a little bit of time to do all of that work on the host. And at the conclusion of that, we get told that the system deployed successfully on the host. And that's followed by a bit of a summary about the build of the online system. And we can see down here that all of the various compiles and links were done successfully with 0 errors. And then it moves into the report phase of the generate. It now starts running target builders to generate the COBOL files for each of the reports. And then once again, it will then pass control to the host to complete the deploy phase for those reports, to compile and link them and install them. And the deploy of the reports is completed successfully. And once again, we finished off with a summary of the reports compile phase. And eventually, the entire build operation has been successful. I'd now like to focus on the development environment. That is, developing an OS 2200 model using the AB Suite development environment. And I'm specifically going to focus on the aspects of that, of modeling, that are a bit different for the OS 2200 platform compared to the other platforms, MCP and Windows. I'd like to start by talking about the validation of model elements against each other. That is, making sure that all elements are in a consistent and valid state against each other. So I'm essentially talking about cross-validation. We refer to these validation rules as model rules, and the validation of them is performed internally by what we call the model rules engine. Now, there has been a significant change in 8.0, and that is that the model rules engine, or the validation of these elements, has been moved to a background thread. So a lot of this validation uses idle CPU cycles. So it's done in the background and it doesn't impact your response time. I'd like to demonstrate a new model rule that exists for the OS 2200, and that is the name uniqueness rule. In AB Suite for Windows and MCP, all classes are namespaces, and therefore the name of attributes within those classes needs to be unique only within that class. For example, you can have, say, group 1, which contains an attribute called data1, and you can also have another group, say group 2, which also has an attribute called data1, because each group is a separate namespace. However, in EAE, the names of all GSD items must be globally unique, regardless of whether they are top-level GSDs or sub-items within a group. The underlying reason for this is that in the generated code at the COBOL level, only the simple name is used and not the fully qualified name. Now, I've mentioned that AB Suite for OS 2200 is generating the same COBOL code into the same runtime infrastructure as EAE. And therefore, we have to enforce the same name uniqueness or name scoping rules as for EAE. Therefore, there is a model rule that verifies this. And I'd like to demonstrate this now. So here I have a group, GSDate, and within it, it has an item GS_DD. Now, outside this group, I'm going to rename another item to have the same name. I'll change this to GS_DD. Press enter. So now the name has been changed, and in the background, the model rules engine has kicked in and verified the new name and has found that there is now a name clash. So we see two errors appear in the errors window. There are two errors because both attributes are in error because of the presence of the other. Now, if I change the name of one of them, then the model rules engine will kick in again and find that there is no longer a name clash, so the errors will disappear. I'll just add an X on the end of the name, press enter. So you might have seen a very short delay there when errors either appear or disappear. And this happens because the model rules engine is doing the validation in a background thread utilizing idle CPU cycles. The following demonstrations of OS 2200 features in the AB Suite developer are taken from demonstration recordings from the technical previews in which these features were first introduced throughout the 8.0 project. Let's start by looking at some of the global attributes. So we've implemented the ability to define attributes at the segment level, so the equivalent of GSDs. And we can have a look in these folders and we can see that we have a few here. These are just primitive attributes. In the globals folder we have some more primitive attributes, this time without a value. And we have another folder here. In EAE, all segment attributes, or GSDs, are added to GSD blocks. In AB Suite, the equivalent of that is a folder with the isUnique property. So here we can see this folder constants, and up here the isUnique property set to true. So that means that this will be generated as a GSD block. All of the attributes within it will be included within that GSD block in the generated code. We can define attributes outside these isUnique folders. So here's an example here. And what we do is we basically gather up all of the attributes that are defined outside isUnique folders, and we generate them into the source code in a default GSD block. We have a folder here called session persist, and this represents a GSD block that is part of GLB work in EAE terms. So this represents, so basically all of the attributes within this will be session persistent, meaning that their value will be retained from transaction to transaction throughout a session. So in EAE, you set the option part of GLB work on your GSD block to define that. In AB Suite, we have this property here, is session persistent block, and it's set to true. So all of these items down here will become session persistent. Their value will be retained from transaction to transaction and allow us to pass data around. Okay, another type of global element that we've introduced is methods, the equivalent of performable global logics from EAE. We have a couple here. So this one, check user login, pretty typical type of global logic. If we have a look at the logic, you can see clearly here it's doing a check to see that a user ID attribute is set, and if it's to check that the user has logged on. And we can do a quick find all references, and we can see that that's used in many places. Very typical usage of a method, a segment method, or a global logic in EAE terms. This one here, convert me, this is a method that does currency conversions. And this demonstrates the use of variables within a method. In this case, this method has some group variables and a primitive variable here. And we can have a quick look at the logic. So this is really just a demonstration method that does a whole lot of different usages of variables, the equivalent of local SDs within a global logic in EAE. Unlike the other AB Suite platforms, MCP and Windows, for OS 2200 methods don't support parameters. So just like EAE, all data must be passed in and out of methods via segment attributes. In this case, you can see that happening up here. Here's a couple of segment attributes here where data is being moved into the method and it's being processed, and at the end of the method we can see a result is passed out in the segment attribute GST result. The next thing we'll look at are the persistence commands. These are the LDL logic commands that we've introduced to process database records. Okay, let's start by looking at some new iSpecs. We've implemented a couple of iSpecs to define products. There's a prod iSpec, simply products, and another iSpec to record stock movements in and out. So when we receive stock, we'll record that. When stock is sold, we'll record that and keep a running tally of the amount of stock on hand. So let's have a look at the lookup command. In the stock IO iSpec, we need to verify the entered product ID. So let's have a look at an example of a singleton lookup. So we need to verify that the product ID entered is valid, and we do that with this command, lookup product ID against the prod iSpec. In EAE, if you have a singleton lookup in an iSpec that fails to find a record, then it will immediately abort or exit this transaction and display an error message. However, in AB Suite on the other platforms, MCP and Windows, that's not the default behavior. The default behavior of a singleton lookup there is that it sets global status to 5 stars and carries on. And it's up to the user to write logic to check glb.status and decide whether to exit the cycle and show an error message or just to continue on. Now, for OS 2200, because we're generating into an OS 2200 runtime, we actually need the EAE behavior. So in order to make that explicit in AB Suite, we've introduced this new keyword on the singleton lookup command, EAE semantics. And that means that this singleton lookup will behave just like a singleton lookup in EAE. The next feature is what I'll refer to as big buffer iSpecs. Most iSpecs that have a presentation type of graphical and fixed or just fixed essentially have a constraint on the amount of data that can be input and output to the iSpec, and that is constrained by the size of the fixed form, which is 24 lines by 80 columns, around about 2,000 bytes. In EAE, there's the concept of a big buffer iSpec, which doesn't have a fixed form at all. Therefore, it's not constrained by that fixed form, and it can have much larger input and output buffers, many more fields, for example. In AB Suite, we don't use the term big buffer, but we have the same concept, and it's driven by the presentation type. So if we set the presentation type to graphical only, it means that that iSpec does not have a fixed form, and therefore its input-output buffer is not constrained by that fixed form, and it can input and output much more data. We have an example of that. It's a similar search contact iSpec, but this one is set to have a presentation type of graphical, so it has no fixed form, and therefore the constraints are off. In this case, we've made it as a copy iSpec, and we've set copies to 30. So let's just open that in the Painter, have a quick look. As you can see, it looks very much like the other search contacts iSpecs, but we have many more lines of display, much more data input and output. It could have more than 30 if we wanted to. Another type of iSpec that in EAE is referred to as a usage output iSpec is one that has no presentation at all, and it just has persistent attributes. So essentially it's designed to define a database table. And we've implemented that. We have an example here. And in AB Suite, we define this simply by setting presentation to none. It has no fixed or graphical presentation, therefore it doesn't participate in the iSpec cycle at all. In this case, all of the attributes in it are persistent, so its only purpose is really to define a database table. The next feature is one that has actually been implemented differently in AB Suite for the OS 2200 compared to AB Suite for MCP and Windows, and that is insertables. First of all, insertables themselves are pretty much the same. So here's an example here. It's an insertable called return to menu. It has a main method. It has an attribute, in my case called return. Let's just open up the logic. So it has a main method with a bit of logic. And it also can have presentation. In this case, this one just has a button. The difference is in the way in which you use the insertable, in the way in which you insert an insertable into an iSpec. In AB Suite for the other platforms, the way you do that is you create an attribute and you template to the insertable. Essentially, you create an instance of that insertable within your iSpec. And then you can refer to the attributes of the insertable with a qualification of the instance name. Now, in AB Suite for the OS 2200, it's a little bit different to that. And the reason is that we needed to model it very similar to EAE because we are still using the runtime environment on the OS 2200 and the generated code is still virtually identical to that in EAE. So we're constrained by that. So the modeling of insertables in AB Suite for the OS 2200 is very similar to the modeling of insertables in EAE. So let's just look at an example. So the way we use an insertable in an iSpec is to create a dependency to that insertable. So I'll open this iSpec to the dependencies window tab, and we see here we've got an insert dependency from this iSpec to the return to menu insertable. Once we have that insert dependency, all of the members of the insertable get copied into the iSpec as first level members. So here we can see the insertable has an attribute return. Well, where we've used this insertable in this iSpec here, we basically get an attribute, a first level attribute called return. There are a couple of aspects of the way that insertable is inserted that are controlled on the dependency itself. So here I've selected the dependency and I have some properties here. One is include presentation. So if the insertable has presentation, I can choose whether or not to include that presentation in each place that the insertable is inserted with this property here. And also we can determine whether, if this is inserted into a copy iSpec, whether the inserted attributes are copied or not. There is a quick way to insert an insertable. So I can go into my logic and type insert and the name of the insertable. Now, initially this will be in error. If we look at the error, it says missing insert dependency. Well, I can just click on the autocomplete options and create insert dependency. So that's actually created that insert dependency. You can see down the bottom here that inserted attribute has come in from the insertable and the error has gone away. The next feature I'll show is the ability to include references to iSpec attributes onto frames. Just looking at one of the reports we had in Tech Preview 3, we've got a report called List Contacts. It was a very simple report, once again. So we just had a lookup loop to read through the CNTCT table, contact table, and print the data. And if we look at frame 10, Frame 10 includes attributes on it for the contact name, email address, mobile phone number, and the logic of that would simply move the data from the record we've read to the attributes on the frame. So in Tech Preview 4, we've introduced a feature that just makes that a little bit cleaner. So in EAE, when you add a frame item, you can put in the name of an iSpec attribute, for example, cus.name, and that creates that attribute, and that's essentially a reference to that iSpec attribute. And when the frame is either printed or extracted, the value in that iSpec attribute at that point in time is printed or extracted. We've introduced a similar capability in this tech preview. So if we look at the new version of list contacts, so first of all, if we look at the main logic, and actually the main logic is identical. So we're just reading through the contact records and printing frame 10. So let's have a look at frame 10. So frame 10 has the same three attributes: contact name, email, and mobile, but it has no logic. If we look at these attributes, you see that they've got a new property, value supplier. And in that, we've entered the name of an iSpec attribute, contact.nam. This email, contact.email. And that value supplier means when this frame is either printed or extracted, the value in this target attribute will be populated into this attribute and printed or extracted. The next feature I'd like to demonstrate is the use of arrays, or specifically setup data arrays. Now, in EAE, the definition of an array creates what's referred to as a selected by attribute. It's a separate numeric attribute that is used to essentially index or subscript into the array. So you move a value to the selected by attribute, and then you refer to the array, and you are implicitly referring to the element of the array defined by that selected by attribute. Now, on the other hand, the LDL plus language in AB Suite uses a much more standard array notation of square brackets with a numeric attribute or expression within it to explicitly define the array element that you're referring to. Now, in AB Suite for the OS 2200, we have wanted to use the standard AB Suite notation of using square brackets to index, but we are still using essentially the EAE runtime environment, and we're constrained by the capabilities of that runtime environment and the code structure of that EAE runtime environment. And that means in AB Suite, we're still using a selected by definition to index into arrays. So let's have a look at that. I have an array attribute here, and we can see that this is it's a string, length 1, quite small, and multiplicity is set greater than 1, in this case 2. So it's just a 2-element array. And we have this property here, selected by, and the target of this property is any other numeric attribute. And so what we're doing is we're defining that this is the attribute that will be used to index into or subscript into the array when we use it. So let's have a look at some logic that refers to array elements. So here we have an example of referring to an element of that array. So it uses the much more standard and much more explicit square bracket notation to explicitly define the array element we're addressing. And notice that in this case, it does use the define selected by attribute within the square brackets. The element of the array is moved into that attribute prior to referring to the array. Now, the interesting thing here is that because we're constrained again by the underlying code structure of the runtime, this must be the selected by attribute. So normally in AB Suite, we might be able to do something like this, which is to explicitly refer to an element of the array, but just by using a literal. But we can see when I do that, we have an error. So if I hover over that, the error says must use selected by GSD_INDX to access an element in this array. Okay, so it's telling me I can't use a literal. Also, I can't use some other numeric item. For example, num1, just some other numeric item. If I hover over that, I get the error message, invalid selected by num1 for dimension 1. Should be GSD_INDX. So what that is telling me is that the only thing I'm allowed to use in here is the defined selected by attribute for this array. And once I've put that in, the errors has gone away. So whereas the logic looks as if it may be a little bit more flexible, it still does actually exist with the same constraints of EAE, of just using that defined selected by to index into arrays. Now in EAE, there are a couple of commands that allow you to work on the whole array, such as clear array and move array. We have implementations of those. So first of all, let's look at clear array. We can use the clear method. So in this case, array.clear. We'll work on that whole array. Now you notice the difference here. So here, my reference doesn't have the square bracket notation, so therefore it is addressing the whole array. Another example is move array. So in this code here, we're moving a string to our array. And once again, we don't have the square brackets following, so this is a command that works on the whole array, as opposed to the use of the array with the square bracket notation where we're referring to a single element of the array. One of the important commands that we've implemented is the ability to call external routines. Now on the screen we have an example from EAE. Data can be passed into an external routine through glb.param. So glb.param is set up, then you call the routine with the call command. So this is calling a routine called hello. And if that routine returns any data, that will come back in glb.param. So let's have a quick look at how that will work in AB Suite. So when you first migrate your EAE system to AB Suite, all of the routines that are called will be collected together and implemented as methods on an external class called call routines. So here's an example in this system. This call routines external class has a method called hello, and it takes a single in-out string parameter. We can see that that parameter is templated to framework.param, which is the type for glb.param. So let's have a look at how that's used in logic. Simple example. So as in EAE, you can set up a value into glb.param, and then here we have essentially the call command. It's the invocation of a method on the call routines external class instance and passing in glb.param as a parameter. So the value goes in and it's an in-out parameter. So if the routine returns data, that value will come out populated into glb.param. So that essentially works exactly the same as a call command in EAE. Now looking at this, you might think that this might be a bit more flexible, that I might be able to use something else there, pass another string parameter. But in fact, you can't. If you do that, you'll see that you get an error on that line of logic. It only accepts glb.param as a parameter. So yes, so at the end of the day, it essentially works exactly the same as EAE, but there is an advantage here. It is a little bit more explicit to the reader of this logic that values are being data is being passed in and out of this routine via glb.param. Another command that we've implemented is compute, and I'd just like to say a few words about that implementation. So let's just go and have a look at an example. So compute evaluates an expression and puts the result into that attribute there. Now, with the expression consists of any number of operands connected with operators, multiplication, addition, division, exponentiation, but there is a predefined precedence of those operators, and that is essentially multiplication and division goes before addition and subtraction. So in this simple example, num2 times num3 will be evaluated first before being added to num1. Now, in the LDL Plus language on the other platforms, you can use parentheses to make your precedence a little bit more explicit. For example, you can do this, which makes it just a bit more explicit that num2 times num3 will be evaluated first before being added to num1. And you can use parentheses to vary that precedence. But for the OS 2200 platform, whereas you can use parentheses to make the precedence a bit more explicit, you can't change the default inbuilt precedence. For example, we can't do something like this. So let's first of all remove those parentheses. And let's say we wanted to do num1 plus num2 first. Well, we can't do that. And you'll see we have an error. And if I hover over that, we can see that it considers that to be an invalid arithmetic expression and explains that the operator precedence is non-standard and we must stick with the standard operator precedence. So we can use parentheses to just make that precedence just more explicit and just the logic be perhaps a little bit more readable, but it still adheres to the existing standard precedence rules from EAE. The next feature I'd like to show is inserted reports. So let's just show an example of it in this model. So here we have a report called skeleton, and it contains a couple of frames. Now these are just general frames that we want to be able to reuse in many other reports. So then in another report, we can insert this skeleton report and get use of these frames. Here's an example. This report here lists contacts 5. Now I'm going to open this with the dependencies window. And here we will see that we have an insert dependency, list contacts 5, inserts skeleton. And it therefore gets all of the frames from skeleton are then inserted into this report. And if we expand that dependency, we can see all of the frames that are inserted. Now, by default, you insert a report, you get all of the frames. You can actually insert just one frame. So for example, if I go to another report and I say add insert dependency, and then I can navigate to the skeleton report. And let's say I just want one of these frames. I can pick the frame I want, and that will insert just one frame. We've now implemented events, and I have a simple example of some event transactions. So here under the folder beta, events, I've included just 2 event transactions. First of all, we have sale, which is selling products to customers, and cash, which is receiving cash payments from customers. And of course, we have the base event set called event, and this represents the event table. As soon as you create your first event iSpec, you will automatically get this event set called event. Now in AB Suite on the other platforms, we have the capability of creating multiple event sets with user-defined names. But in the OS 2200 version of AB Suite, we are constrained to what the existing runtime environment supports, and it supports just one event set called event. So that's all that we have in the OS 2200 version of the model. The base event set does include a superset of all persistent attributes from all of the events, and it contains any event profiles. In this case, I just have one cust_trans, which gives me all customer transactions sorted by customer and date time. As I said, AB Suite on the other platform includes multiple event sets, and therefore there is a relationship between each event ISpec and the event set that represents the table. And that's represented by this property here called event set. Even though for OS 2200 we just have a single event set called event, you do have to set up this property. When you add new persistent attributes to event ISpecs, they don't automatically appear on the event set. There is an easy way to do that. I'll just add an attribute now. You can see here we have a new attribute within our cache event. I can right click on that and go to quick actions and do this item, create sync auto persistent members. And that will sync up those new members from cache and they will now appear on event. So if we go to event, there is our new attribute appearing on the base event set. I'd like to finish this demonstration by pointing out a couple of new options that are available on the host login dialog at the beginning of a build. Install system and reports. So by default, this is checked. This means when you do a build, it will compile all of the ISpecs and reports and then install them, reorganize the database and install the new executables. If you uncheck this, then it will compile everything and have everything ready to install, but will stop just short of the install phase. Then you can come along later and run the LRU configure process at the appropriate time to complete the installation, to reorganize the database and copy in the new executables. Another option is this one, revert to standard layout. So normally when you add new columns to a table, they will be added at the end, meaning that a reorganization of the data is not necessary. However, if at any time you want to revert the layout, the column layout of those tables back into the standard layout, which has all the columns sorted in alphabetical order, then you can check this checkbox. Now in EAE, you were able to do that table by table, but at this stage with AB Suite, we just have the option at the whole build level. So if you check that checkbox, it will revert all tables to the standard layout. I'd now like to talk about the auto entry commands. For the OS 2200, we have a new implementation for the ability to store records into the database from LDL logic. The LDL plus commands for doing this are substantially different to how this is done in AB Suite for the other platforms, that is MCP and Windows. On those platforms, the technique is to populate an AB Suite object using move or assignment commands and then call the store method. When migrating an EAE model to AB Suite for MCP or Windows, the original EAE LDL logic that uses commands such as auto entry, auto write, and so on, is migrated to corresponding LDL plus using move and store. Note that these platforms don't have the concept of an auto buffer and therefore sometimes make use of two instances of the ISpec to mimic the auto buffer behavior. With AB Suite on OS 2200, one objective is to generate COBOL that is largely identical to that generated in EAE. We found that it wasn't really practical to achieve this from the migrated LDL Plus that uses move and store. Therefore, for AB Suite on OS 2200, we've implemented new LDL Plus commands that have a one-to-one correspondence with the auto entry related commands in EAE. This table shows the EAE LDL commands on the left and the new AB Suite LDL Plus commands on the right. As you can see, we've implemented new LDL Plus commands that correspond to each command from EAE. The only difference is that we've used LDL Plus conventions regarding the exact format and syntax of each command. Here is an example of some EAE LDL on the left and what it will look like after being migrated to AB Suite LDL Plus for the OS 2200 on the right. I'd like to make a few points about the names of some elements. With elements like iSpecs and reports, they can have longer names which can be used in the model and logic within the development environment. But those elements also have an alias property, which is a short form of the name. And it's that alias which is used in the generated code. For example, you can have an iSpec called customer, and it would have an alias of something like cust. And the name cust is what it would be known as in the runtime system or in the runtime code. Frame names. In EAE, all frames are identified with a simple 2-digit name. Well, in AB Suite, frames can have a free format name, but that name must end in a 2-digit number, and that number must be unique within the report. For example, frame 10, consolidate 35. And it's that 2-digit suffix that is used in the generated code. In EAE, extract files and output streams, or shadow reports, are identified with a single alphabetic character. In AB Suite, they can have a free format name, but the first character of that name must be unique within the report. For example, A file, C extract, product file, and it's that first character which is used in the generated code. I'd like to finish this Nibbit presentation by saying a few words about some limitations. Now, in EAE, there are a large number of features and functionality, a lot of different types of elements, a lot of commands, and implementing every last one of them has been a very big job. What we did up front is we had a look at the models from our known customers. Those are the customers that are using EAE on the OS 2200 that we knew about. And we looked at the features that they used and the features that they didn't use. And we made sure that we prioritized the features that they used. Now, as it's turned out, there are a handful of features which didn't get implemented. And these are all features that are not used by any of our known customers. And some examples are listed here: keywords, callable segment methods, the glb.financial methods, or what is the discount cash command in EAE, and component data arrays. We've now come to the end of this Nibbit presentation on AB Suite for the OS 2200 within 8.0, and I'd like to thank you for your time, and I would wish you well with using the product. Thank you.